connect together a concept we've been talking about in this section, curl, with something from way earlier in the class, the gradient here. And so the way that these two are connected is by the following identity. The curl of the gradient of some scalar value function f is equal to the 0 vector. Or we can write it in the following notation. The curl of the gradient of f is equal to the 0 vector. So first off, let me point out here that this notation is very, very suggestive of what's going on here. We know from way back in chapter 12 that the cross product of a vector with itself, or a cross product of a vector with a vector parallel to it, is guaranteed to be 0. So this is certainly suggestive. But if we want to provide a more formal proof, we can do that. And all we have to do is just write out partial derivatives and second partial derivatives and stuff like that. So if we want to compute the curl of the gradient of f, well, let's just remember the gradient of f is going to be partial f partial x, partial f partial y, partial f partial z. So writing this out as a cross product, partial derivative with respect to x, y, and z. And then we fill in this as our third row here, partial f partial x, partial f partial y, partial f partial z. And we end up with I hat times the partial derivative with respect to y of partial f partial z. So that is f sub zy minus the partial derivative with respect to z of partial f partial y. That's f sub yz. And then we have minus j hat times, similarly, you can crunch this out. It will be this, the partial derivative with respect to x of this, minus the partial derivative with respect to z of this. So that is f sub zx minus f sub xz plus k hat times, I'll just write out the last one here, fyx minus fxy. And we should know that, assuming that our partial derivatives exist and are continuous, assuming everything is nice here, these equal, these equal, these equal, so 0, 0, and 0, and so you end up with a 0 vector here. So this is a nice little connection between curl, something we were just talking about here, and gradient from way back in chapter 14.